So yeah, I'm gonna record the session and so we can start. All right, so this is section 2.5, right? This is about zeros of polynomial functions. And so the main theorem in this section is the rational zero theorem. So let me just remind you the rational zero theorem. So this is the main theorem in this section. So the rational zeros theorem. So so the theorem says the following. So we have a polynomial. So f of x, it's a polynomial. So we have x to the power n. In front of x to the power n, there is some coefficient, a subscript n, etc., plus some powers of x, etc. And then at the end, you have some constant, a subscript n, a subscript 0. So this is a polynomial. I'll be a polynomial. And so the theorem says that actually the list of possible rational zeros of f of x are, so this list is given by the factors of the constant. So the constant, that's the number by itself, so the a0 over the factors of the leading coefficient. So that's the number in front of, or the coefficient in front of the highest power of x. So here's my leading coefficient, right? A subscript n. Anyway, so yeah, so the theorem gives us the list of possible rational zeros. So now, how can we use, so the question we're gonna try to answer, so how can we use this theorem to factor the theorem to factor f of x completely, to factor f of x completely. Right? So here's an example. So this example is going to be similar to the problem 5 and 6 in the homework. So example. So this is similar to the problem 5 and 6. Problems 5 and 6 in the homework. Right? So let's say let f of x be equal to, let's say it's 3x cubed plus 8x squared minus 15x plus 4, right? First question is, of course, first question would be to list all possible rational zeros. So when I say zeros, guys, I mean solutions of f of x equal to 0, right? Possible rational zeros. 2, factor f of x completely. Right. 3, find the x-intercepts and their multiplicities. Find the x-intercepts and their multiplicities. right? For, let's say, find the y-intercept. Find the y-intercept. Five, the behavior of f of x at infinity. So determine the behavior of f of x at infinity, and finally graph f of x, behavior of f of x at infinity, and then 6, sketch the graph of f of x. So graph f of x. All right, let's start with number 1. Right? So possible rational zeros. Well, so number 1. So we said we have to take, so the list of possible rational zeros. So we said we have to take so the list here. Oops. So the list would be, so first we take the factors of the constant. So here the constant is 4, right? That's the number by itself. So the factors of 4, that's my constant. Factors of 4 over, and then factors of the leading coefficient. So the leading coefficient, of course, that's the number or the coefficient in front of the highest power of x. The highest power of x, of course, is 3. So the coefficient in front of x cubed is 3. So the factors of 3. Right? Now, so the factors of 4. Well, so that's the, so 4 is divisible by 1, divisible by 2. It's not divisible by 3, and of course it's divisible by itself. Now factors of 3, 3 divisible by 1. It's not divisible by 2, but then of course it's divisible by itself, right? And then we said we have to divide each of the factors here in the top by each of the factors in the bottom. So 2 divided by 1 and 3, and then 4, this 4 here divided by 1 and 3, right? So then the list would be, so the answer, find answer. So the list of possible rational zeros. So we have plus or minus 1. 1 times 3, that's 1/3. 2 times 2 over 1, of course 2 over 3, that's 2/3. 4 over 1, it's 4. And 4 over 3, of course, that's 4 over 3. Plus or minus, don't forget, it's always plus or minus, right? It doesn't matter if you have factors of 4 or factors of -4. In the list, you will always take the plus or minus, right? Anyway, so that's the list of possible rational zeros. Any question, guys? Please feel free to interrupt me if you have any question, right? Now, number 2. So the question in number 2 is to factor f of x completely, right? So how are we gonna factor this f of x completely? So this is number 2. So first step 1, you have to check the numbers in the list and find one solution of f of x equal to 0. So check the numbers in the list and find just one solution. Find one, right, solution of f of x equal to 0. Okay, so once you find one solution, then you can divide. So in step 2, divide your f of x by x minus the solution we got in the step 1 minus the solution in step 1. All right. Now, when you divide, of course, you're gonna get the quotient. And so in the step three, so you have to factor the quotient completely. Okay. So once you factor the quotient completely, then of course you can factor f of x, completely, right? Okay, so let's follow those steps and to factor the f of x completely, right? So step one, we said check the numbers in the list and see if one of them is a solution, right? So let's see. So this is step one. This is step one. All right, so let me just write down first f of x. So let me just remind you, f of x was 3x cubed, plus 8x squared minus 15x plus 4, right? So first number in the list is, of course, well, we have plus or minus 1, right? So first number, let's say it's positive 1. So we're going to check positive 1 to see if it's the solution of f of x equal to 0. So I'm going to check positive 1. Right. So what I'm going to do, I'm going to plug positive 1 in f of x, right? So that's 3 times 1 cubed plus 8 times 1 squared minus 15 times 1 plus 4. So that's 3 plus 8. So this is f of 1. 3 plus 8 minus 15 plus 4. So that's 11 minus 15. That's negative 4 plus 4, and that's 0. So if you get 0, it means that 1 is the solution of f of x equal to 0, right? So if you don't get 0, you have to check the next number. So here I got 0. So now I am done with the first step. So then x equal to 1 is the solution of f of x equal to 0. Right? So here I'm kind of lucky because the first number I checked was positive 1 and it was the solution, right? If it's not a solution, so we have to continue with the other numbers in the list, right? Until you get a solution of f of x equal to 0, until you get, a solution, right? So my advice, guys, if positive 1, let's say, and negative 1 are not solutions, then the next number in the list would be, here, that would be 1/3, right? Or plus or minus 1/3. So my advice is probably first check the whole numbers. So I would check after plus or minus 1, I would check plus or minus 2, right? Rather than the fraction, the 1/3. And if the plus or minus 2 doesn't work, I would check the plus or minus 4. And then once you are done with checking the whole numbers, then you can check the fractions, because the whole numbers are easier to check than the fractions, right? Anyway, but here in my case, I got positive 1 solution. So that's good. So I can stop here and I can move to the next step. So what's the step 2? We said we have to divide the f of x by x minus the solution in the step 1. So I have to divide. So this is step number 2. So we have to divide f of x by x minus the solution I got in step 1. So the solution I got is positive 1. So it's x minus 1. Right? So I have to divide f of x by x minus 1. And so my c, of course, divide by x minus 1. So my c is positive 1, right? This is the opposite, right? Okay, so now let's divide. So here's my c, it's positive 1. Now my f of x, we have 3x cubed plus 8x squared minus 15x and plus 4. Constant here is 4. All right, so bring down this 3 here. 3 times 1 is 3. 8 plus 3 is 11. 11 times 1, it's positive 11. minus 15 plus 4 is negative 4 times 1. It's negative 4. 4 plus 4, sorry, 4 plus negative 4 is 0. So as expected, remember, because 1 is supposed to be a solution, so the remainder must be 0. If you don't get 0, guys, then there is a mistake somewhere. So as expected, 0 is our remainder, right? So, and so what will be my quotient? So this is 1 degree less. So here it should be x squared. This is x, and here's my constant, right? This is this whole thing here, of course, that's my quotient, right? So, so what's the conclusion from this? This is step 2. So the conclusion is that my quotient is 3x squared plus 11x minus 4. And so my f of x, of course, that will be the divisor, x minus 1. I divided by divide f of x by x minus 1, right? So f of x would be my divisor times the quotient. So times the quotient, which is, of course, 3x squared plus 11x minus 4, right? And of course, we should have plus here, should be plus the remainder, right? But the remainder is 0, so that's why it's just plus 0. So then we have nothing here, right? So it's because the remainder is 0. All right, so I got my quotient, and so next step. So remember, guys, the goal here is to factor f of x completely, right? So here you can see, and this is step 2, I got like partial factorization of f of x, right? I got x minus 1, that will be my first factor, but then we need to factor the quotient, right? So that's the step 3, right? So the step 3, you see here. So in the step 3, we have to factor the quotient, right? So how do we factor the quotient? Well, so this is step 3. Well, here the quotient is a quadratic function, right? So my quotient is 3x squared plus 11x minus 4 as a quadratic function, right? So I want to factor this. So factor the quotient. So here we have to factor the quotient, right? And it's because it's a quadratic function, so we can solve the quotient equal to 0, right? Once you solve the quotient equal to 0, then you can factor your quotient, right? So I can so I have to solve this 3x squared plus 11x minus 4 equal to 0. Again, there are different ways to factor this quadratic function 3x squared plus 11x minus 4. I would say the easiest way would be just to solve the quotient equal to 0 using the quadratic formula, right? And then you will see it's very easy to use the solutions to factor the quotient. If you know another way to factor the quotient, because if you know another way to factor, the quadratic functions, then that's fine. You can. It's up to you. You can wherever you are familiar with, right? So anyway, so if you decide to use solve the quotient equal to 0, so then the solutions using quadratic formula, so that's minus b plus or minus square root of b squared minus 4 times a times c, right, over 2a, right? So then your x would be negative 3 plus or minus square root of, so 11 squared, that's 121. And then minus, that would be a plus here. This is minus, that would be a plus. So 11 squared plus 4 times 3 is 12. 12 times 4, that's 48. So 121 plus 48, that's 161. Sorry, 169, right? Over 6. So then x, that's negative 3 plus or minus. Square root of 169 is actually 13. So this is plus or minus 13 over 6. So either x is negative 3 plus 13 over 6. So that would be 10 over 6. Sorry, here I said minus b. It should be minus 11. I put minus 3 here. Sorry, this should be minus. Sorry. So this is minus b. So it should be negative 11. Sorry, it's not negative 3. So negative 11 here. Negative 11. Negative 11. So negative 11 plus 13. That would be 2. So 2 over 6. You reduce a fraction. So that's 1/3. Right, and or of course negative 11 minus 13 over 6, that would be negative 24 over 6, and 24 over 6, that's 4. So this is negative 4. Right? So here I got these two solutions, the 1/3 and negative 4. Now, how I'm gonna factor my quotient? Well, so here's the answer. So remember, guys, my quotient was the 3x squared plus 11x minus 4. So then the factorization of this quotient is going to be, so that will be equal to, so we're going to have x minus the first solution, right, times x minus the second solution, right? So my solutions are 1/3 and negative 4. Just one thing, one more thing, guys, because here you see when you multiply x by x, you get x squared, but this is 3x squared. So you have always to put this number here, wherever you have in front of x squared, in the front here. So here we're going to have this 3, right? So it's 3 times x minus the first solution times x minus the second solution. So that will be, so our quotient, so it's going to be 3 times x minus first solution. So that's the 1/3. So x minus 1/3 times x minus the second solution, which is negative 4. So x minus negative 4. Okay, so this is a complete factorization of your quotient. Right? And then, so once you get complete factorization of your quotient, then we can answer. Remember, guys, the goal was here. So what we are doing is we want to, so just to remind you what we are doing here. Where is it? So we want to factor f of x completely, right? We want to, you see here, we want to factor f of x completely, right? So we said there are 3 steps. First step, we have to check the numbers in the list of possible rational zeros. Then step 2, we said we have to divide f of x by x minus the solution. Now the third step, we said we have to factor the quotient, right? And then because, so now I can answer the question. So then the complete factorization of f of x, so conclusion, we'll find answer, so conclusion. So remember, f of x was equal to, at some point in the step 2, we said f of x is equal to, x minus 1. Here's my f of x. So we said it's x minus 1 times my quotient, right? So it's x minus 1. It's x minus 1 times my quotient, which is 3x squared plus 11x minus 4. Now, this is step 2, but in step 3, we factored the quotient, right? So it's x minus 1 times, So then this quotient here turns out to be, 3 times x minus 1/3 times x minus this -4. Right? That was my quotient. So, so in other words, this is f of x. This f of x is equal to, so I'm going to move this 3 here into the front, this 3 here to the front. So that's actually 3 times x minus 1 times x minus 1/3 times x minus -4 minus, that will be plus, so it's actually x plus 4. All right, so this is the complete factorization of your f of x, as you can see. So this is the answer to the number 2, right? This is the complete factorization of f of x. Of f of x. Right? Any question, guys? So first, I tried the numbers in the list. I got one solution, and then I had to divide my f of x by x minus that solution, right? I got the quotient, and then I had to factor the quotient, right? And then you get the complete factorization of f of x. All right, so if there's no question, then we can move to number 3. So number 3, we have to find.
I have a question.
Yes, please. Yes.
Do we have to choose only one answer on the list to do all that work?
Yeah, just one answer. Yeah, if you, here, I just tried one answer because it worked, because I got 0, right? You see here, when I plugged 1, when I plugged 1, here, f of 1, I got 0, right? I got 0. Because I got 0, then it means that 1 is the solution. So I can stop and move to the next step. But if you don't get 0, if this is not 0, right, then you have to try the next number until you get 0, right?
Okay, I got it. Thank you.
Sure. So then, okay, so then I can move to number 3. Find the x-intercepts and their multiplicities, right? Find x-intercepts and their multiplicities. Well, here, guys, all the work is done in number 2. So because how do we find x-intercepts? We have to solve f of x equal to 0, right? But then I know my f of x from number 2, f of x is 3 times x minus 1 times x minus 1/3 times x plus 4. So that's the point. So that's why we factor f of x completely, because now f of x is the product of factors. And if you want to solve this equal to 0, right, and you have only product, so this is just a product of factors. So if you have a product of factors equal to 0, then one of the factors is 0. Then either the x minus 1 is 0. Of course, 3 cannot be 0. I mean, this factor 3 here cannot be 0. But then x minus 1 is 0, or the x minus 1/3 is 0, or the x plus 4 is 0. So of course, x minus 1 is 0, then x is positive 1. X minus 1/3 is 0, then x1 is 1/3. X plus 4 is 0, then x is -4. Okay. So those, plus 1, positive 1, 1/3, -4, they are my x-intercepts. So, so the answer, answer to number 3, so the x-intercepts are, so positive 1, 1/3, and -4. Right. And now, what about their multiplicities? Well, all the factors here, they have power 1. This is power 1, this is power 1, and this is power 1. So all the x-intercepts, they have multiplicity equal to 1. So, and all of them are of multiplicity positive 1. Okay, because you see here, the powers, all of them, the powers is 1, right? Any question about this multiplicity thing?
Wait,
Of course, for example, if I got, yes, please go ahead.
could you, when you're done, could you move upward so that I see something?
Excuse me, I didn't hear you.
I said when you're done, could you move down? Wait.
Oh, like
upward.
this? To the top or?
Yeah, to the beginning.
Okay. Right here?
From the beginning, where you found the rational.
Rational, the list of possible rational zeros?
Yeah, yeah.
Oh, okay. You mean like, I guess, where is it? Right here?
Yeah.
Mm-hmm.
Okay.
Anyway, so yeah, I was saying the multiplicity of the, multiplicity of the x-intercepts is equal to 1 because again the powers of the factors are is just 1, right? So next, guys, we're supposed to do the y-intercept, right? So for number 4, are you done with this?
Oh yeah.
Okay, perfect. Thank you. So for number 4, guys, you want to find the y-intercept. So here, so number 4, the y-intercept. So this is similar to the problem 5 and 6 in the homework. So for the y-intercept, guys, all you have to do is to evaluate f of 0, right? Just plug 0 in the function f. So f of 0, that would be that would be 3 times 0 cubed plus 8 times 0 squared minus 15 times 0 and plus 4. So the answer, so f of 0 is 4, and so y-intercept is of course is 4, 0, 4. So the y-intercept is 4. Next, the behavior at infinity. So just to remind you, so your f of x is 3x cubed plus 8x squared minus 15x plus 4. So the degree, the highest power of x is 3. So the degree is equal to 3. That's odd. And the leading coefficient, the number or the coefficient in front of the highest power of x is 3, and that's positive. So the leading coefficient is positive. Right? And if the degree is odd and the leading coefficient is positive, then we are in the following situation. So we have, so let's say this is a graph of f of x. So at negative infinity, the graph of f of x is gonna be right here in the bottom, and it's gonna go all the way up here. Okay, so that's the behavior of f of x at infinity. 6, I can now graph. I can now graph f of x. So 6 here. So graph f of x. So so we said at infinity we're gonna so the graph is gonna be right here and right here. We need to plot the x-intercept, guys, and the y-intercept. So plot the x-intercept and the y-intercept. So x-intercept, we said we had -4. So let's say -3, -2, -1. So this is -4 here. 0, we have 1/3. So let's say this is 1/3. This is +1, 2, 3, and 4, etc. Right? And the y-intercept is 0, 4, 1, 2, 3, and 4 right here. So first you plot the x-intercepts. So -4, the 1/3, and the 1. Plot the y-intercept, it's 0, 4. So here's my y-intercept, it's 0, 4. And then all you have to do is to join the points. So we start from the bottom right here. You go to -4. So now -4, so the question is, do we cross the x-axis or just touch it and turn around? Well, multiplicity of the x-intercepts is 1, right? And 1 is odd. So if it's odd, so you can cross your x-axis. You join the next point, which is the y-intercept. Next point is the 1/3. But at 1/3, guys, the multiplicity is odd. So we're gonna cross the 1/3 and then join 1 and 1. We're gonna again cross the x-axis because the multiplicity is odd, and then go all the way up here, right? And so that would be my function f of x. Okay, so again, guys, because the multiplicity of the x-intercepts is 1, so that's odd, and when the multiplicity is odd, we just cross the x-axis. You don't have to you don't turn around, right? You cross the x-axis. Any question, guys? So this is similar to the problem 5 and 6 in the homework, right? So here's an exercise. Right, so exercise. Yeah, sure. Yeah. So an exercise. So similar exercise. Exercise. All right. Okay, so I'm going to give you a similar problem so we can practice a little bit. So let's say f of x equals to, so -3x cubed, right, minus 7x squared plus 22x plus 8, right? So what you have to do, guys, first, 1, 2, 3. So 1, list all possible rational zeros, right? Then 2, factor f of x completely, and 3, find the x-intercepts and their multiplicities. And their multiplicities. Right. Well, we won't do the 4, 5, and 6. I mean, we won't find the y-intercept, the behavior at infinity, and graphing the f of x because I mean, we already did similar examples in I think a week ago, right? Anyway, so I'm gonna give you guys let's say 5-10 minutes to find, I mean, for this exercise, right? If you have any question, of course, please let me know, right? So of course this is 22, right? This is 22.
Professor,
Yes.
is that 22 or 23? I
No,
can't
that's
see
20. No, that's 22.
22. Okay.
22, yes. This is 22. And this is negative minus 7. So I guess here in this example, guys, the positive and the negative one, they won't be solutions of f of x equal to 0. So my advice again is to try first the whole numbers before moving to the fractions, right? Yes, Samira, absolutely. Yeah, 2 is gonna be yes. Yes, positive 2 is gonna be a solution. Yes, absolutely. Well, I mean, if plug 2 in the function f, Kwame. So Kwame, I mean, so you divided your f of x by what? Because the remainder should be 0. No, but not by -2, should be +2. So, I mean, like in our example, yeah, well, because, yeah, you divide by x minus 2, so your c should be, it should be +2. So, like, where is it? So you see here, we got 1, x is equal to 1 is a solution, right? So we have to divide by x minus 1, right? But so the c, of course, the c is it's positive 1. So if you say x is equal to 2 is a solution, if 2 is a solution, you have to divide by x minus 2, but then your c, of course, it would be +2.
This is supposed to be the constant 0.
Yes. You mean the remainder is 0?
Yes.
Yes. Yes. Yeah. Yeah. No, you don't need to change it, Kwame. So the c would be equal to the solution, but when you divide, you have to divide by x minus that solution. So yeah, you don't really need, yeah, you don't need to change it.
Actually, when we use 2 and we try to divide, it doesn't
Mhm.
come constant 0. So I think it's 1/3. I don't know, but I'm facing problem. When I divide, it doesn't come the constant 0 with 2.
That's weird. I mean, probably you made a mistake with the sign or something.
I don't know, but when I did it with the 1/3, it came up.
Oh, with the 1/3 came. Okay.
Uh,
Yeah, I mean, if it works for 1/3, then it's fine.
Actually equal to 0.
Yeah, it should be 0 when you use 2, yeah. So any guess for the x-intercepts? So we talk about 2, 1/3, -1/3. Yes, Samira. Yes, that's correct. That's very good. That's very good. Yes, absolutely. Yeah. Yeah, -1/3, 2, and -4. If you are done with the exercise, guys, you can try so the y-intercept and try to graph the function f if you want. Of course, and the behavior at infinity. So as I said, guys, homework number 6. So it's due this Wednesday, and we do have class on Wednesday, right? It's Veterans Day, but we do have class on Wednesday. However, November 25th, so the Wednesday just before the Thanksgiving, that will follow the Friday schedule. So so November 25th, we won't have class. So, and probably I will let you know next week about the date for the test number 2 and the final. All right, guys. I don't know if you need more time, or are you done? I guess probably you're done. Well, so let me start with number 1 first. Number 1. So the list of possible rational zeros. So the list of possible rational zeros. So we're gonna have factors of the constant. So the constant here, the number by itself would be 8. That's the 8 here. So that's so the factors of 8 over the factors of the leading coefficient. That's the coefficient in front of the highest power of x. So that will be -3. So factors of -3, right? Now, what will be the factors of 8? So that will be 8 divisible by 1, by 2, not by 3, by 4, and then by itself. Now, factors of -3. So as I said, it doesn't matter if it's -3 or +3. So for the factors, it's always plus or minus. Okay, so it's plus or minus, so 3 divisible by 1, of course, not by 2, and then by itself. Right, so then the answer here, so the list would be, so 1 divided by 1, 1 divided by 3, 2 divided by 1, 2 divided by 3, 2/3, 4 divided by 1, 4 divided by 3, and then 8 divided by 1, that's plus or minus 8, plus or minus 8, and then divided by 3. Right, so this is our list. Now, we're gonna factor f of x completely. So first, step 1, we said we have to try to check the numbers in the list if they are solutions of f of x equal to 0. So first, so let me write down here f of x for you. So f of x is the -3x cubed minus 7x squared plus 22x plus 8, right? So first number in the list, first whole number in the list. So as I said, first try the whole numbers. So first whole numbers in the list is positive or -1. So we're gonna plug positive, negative, positive 1 first. So f of positive 1. So that will be -3 minus 7 plus 22 plus 8 So negative 10 plus 22, that's plus 10, plus 12, plus 8, that's plus 20. That's not 0, so that's not a solution. So I have to check the next number. So next whole number is negative 1. So negative 3 times negative 1 cubed, that's negative times negative, that would be positive 3. Negative 1 squared, that's positive 1, so minus 7. 22 times negative 1, so minus 22. And then there's plus 8, that's negative 4. Negative 26 plus 8, that's negative 26 plus 8, that's negative 18. That's not 0. So we have to check the next number. So as I said, guys, next number in the list will be the fraction 1/3. But as I said, because the whole numbers are easier to check than the fractions, so instead of checking 1/3, I'm gonna check the 2, plus or minus 2. So let's check positive 2. All right, so f of positive 2. So let's see. So that's negative 3 times 2 cubed minus 7 times 2 squared plus 22 times 2 plus 8. So negative 3 times 2 cubed, that's 8. Negative 3 times 8, that's negative 24. 2 squared, that's 4 minus 7, that's negative 28, plus 44, plus 8. So negative 24 minus negative 28, that's negative 52, plus 44, plus 8. Negative 52 plus 44, that's negative 8. So that's negative 8 plus 8, and that's 0. So I got, you see here, I got my 0. And so I'm gonna stop here because x equal to 2 is a solution, right? So x is equal to 2 is a solution of f of x equal to 0. Right? So I don't think, I think negative 1/3 is gonna be a solution, not positive 1/3, right? But anyway, so and the test and in the final, guys, of course, so probably you're gonna have a similar problem. And so as I said, try the positive negative 1. If it doesn't work, check the next whole number, not the fraction, because otherwise the fraction sometimes would take a lot of time, right? If you check the fractions. Anyway, so this is positive to the solution. So now I can move to the next steps. Step number 2, we said we have to divide f of x. So divide f of x by x minus our solution. So our solution is 2. So it's x minus 2. So as I said, the c, it's just the same as the solution. So c is the solution is equal to the positive 2. But when I divide, I have to divide f of x by x minus 2. My x minus the solution. So x minus solution is going to be a factor of f of x. But anyway, so let's divide. So so here I'm going to put my c, it's positive 2. Here my f of x. So my f of x is a negative 3x cubed. And then x squared, we have minus 7. X squared for the x. So for the x, we have plus 22x, so here's plus 22. Then for constant here, we're gonna have plus 8, right? So as usual, division of polynomials, bring down the first number. So this is negative 3 here, that would be negative 3 here, of course. Now you multiply the last row by the c, right? Here we'll multiply. So 2 times negative 3, that will be negative 6. So here's my negative 6, negative 7 plus plus negative 6. This is a plus here, so that'll be negative 13. Negative 13 times 2, that's negative 26. That will be negative 4 here, 22 plus negative 26. Negative 4 times 2, that's negative 8. And positive 8 plus negative 8, of course, that will be 0. So as expected, because 2 is a solution, so the remainder is 0. And this is going to be my quotient, right? And the quotient, guys, again, it's 1 degree less. This is x cubed. So here we're going to have x squared, x, and then a constant, right? So just to answer the step number 2, so the quotient, so answer to the step number 2, so the quotient would be negative 3x squared minus negative 13x minus 4, right? And so my f of x is the divisor. I divide by x minus 2 times the quotient times the negative 3x squared minus 13x minus 4, right? Again, this is my divisor times the quotient, right? And plus the remainder is 0, right? So that's my f of x. Any question, guys, about this step number 2? All right, so then I can move to the step number 3. So in the step number 3, we have to factor the quotient completely. So this is step number 3. So in the step number 3, we have to factor the quotient. So again, the goal, guys, is to factor f of x completely, right? And so here I got the first factor, x minus 2, but now I have to factor this quotient, right? The negative 3x squared, etc. So we have to factor negative 3x squared minus 13x minus 4. So how do we factor this? One possible way to factor the quotient, because it's a quadratic function, so we can use a quadratic formula. So we can solve. So negative 3x squared minus 13x minus 4 equal to 0. Use the quadratic formula. So my x would be minus negative 13 plus or minus square root negative 13 squared. That's 169 minus 4 times a times c over 2a, right? 2 times negative 3. So this is here negative 3 times negative 4, that's positive. So this is actually x. So your x is going to be, oops. So your x is going to be minus negative 13, that's positive 13, plus or minus square root of, so 169 minus, so 4 times 3, that's 12. 12 times 4, that's 48. 169 minus 41, 169 minus 48, that's 121 over negative 6. So your x is 13 plus or minus square root of 121, that's 11, right, over negative 6. So either your x is, so x is 13 plus 11 over negative 6. That's 24 over negative 6. That's negative 4. Or x is 13 minus 11 over negative 6. That's 2. Positive 2 over negative 6. And you reduce a fraction, of course, divide by 2. So that's negative 1/3. Right? It's negative 1/3. So now I can factor my quotient. Right? So here's the answer to the step number 3. So now I can factor. So answer to the step number 3. So then my quotient. So just to remind you, the quotient was negative. Where is the quotient? So it's negative 3x squared minus 13x minus 4. So negative 3x squared minus 13x minus 4. And so we said, how do we factor this? So because it's a square, we expect two solutions. So we're gonna have like x minus the first solution times x minus the second solution, right? And here are my solutions, right? So the negative 4 and the negative 1/3. But then just don't forget, because this is negative 3x squared, here x times x, that will be x squared. So I need to put this negative 3 here in the front. Here. Okay, so it's negative 3 times x minus first solution times x minus second solution. So that will be, so your quotient, so it's going to be negative 3 times x minus first solution, x minus negative 4, times x minus the second solution, negative 1/3. Right, so this is a complete factorization of my quotient. Now I got a factorization of the quotient. Now I can answer the question. So conclusion. So the complete factorization of f of x. So conclusion. The complete factorization of f of x. Remember, f of x was, we said at some point, f of x in the step number 2. You see here, we said f of x is this x minus 2 times the quotient, right? So f of x is x minus 2 times the quotient. So it's x minus 2. So it's x minus 2 times the quotient times the negative 3x squared minus 13x minus 4. But now, from the step 3, the quotient turns out to be, so this is x minus 2 times, so my quotient turns out to be negative 3 times x minus negative 4 times x minus negative 1/3. Okay. So in other words, so the final answer, so I'm going to move this negative 3 to the front. All right. So it's negative 3 times my x minus 2 times x minus negative 4, so that's x plus 4, times x minus negative 1/3, so that's x plus 1/3. Right? This is, as you can see, guys, this is minus minus, that will be plus, and here minus minus, that will be plus. So this is the complete factorization of f of x. So this is a fine answer for number 2. So this is the complete factorization of f of x. Complete factorization of f of x. Right. Any question, guys? All right, so now I can move to the number 3. I can find my, sorry, oops. What did I do here? Okay. Okay, I have to go to the, sorry. All right, okay, perfect. So, so this is step number 3. Sorry, not step number 3, but this is question number 3. So now I have to find the x-intercepts. And their multiplicities. So remember, guys, x-intercepts, all you have to do is to solve f of x equal to 0 and their x-intercepts and their multiplicities, right? So the point why we are we factored f of x completely, because now I can write, so I want to solve, right, f of x equal to 0, right? I want to find the x-intercepts. So now what's my f of x? Well, it's -3 times x minus 2 times x plus 4 times x plus 1/3 equal to 0. But because you see, guys, now my f of x is a product, just product of factors equal to 0, then one of the factors must be 0. So then that's why we had to factor completely f of x, because once you factor completely f of x, then you can solve very easily the f of x equal to 0. So because it's a product, this is really important, it's a product which is equal to 0, then either the first factor is -3, but -3 cannot be 0, right? It's not 0. So either the x minus 2 is 0, or the x plus 4 is 0, or the x plus 1/3 is 0. Right? So then, of course, x minus 2 is 0, then x is positive 2, x is -4, and then x is -1/3. Right? So then the answer is question. So the x-intercepts, so find answer here. So the x-intercepts are 2, -4, and -1/3. And all of them, the power here, the power of factors here, this is power 1, this is power 1, this is power 1. So all of them, they have power 1, right? So then all of them have multiplicity equal to 1. So, and all of them have multiplicity equal to 1. Multiplicity equal, so this is equal to 1, right? Because the power of the factors, the power of all the factors is 1. Any question, guys? All right. Now questions. So good. Okay, so actually we are done with this section 2.5. So we have like 20 minutes. Probably instead of, I can start section 2.6, or we can have one more example, a little bit different. Probably 20 minutes, that's not enough, start section, next section. So let's have one more example. And this example is kind of different from this one because, so let's move. So you will see why it's kind of different. So let's exercise. Now, let's say f of x is a polynomial of degree 4. Okay, so f of x, this is x fourth minus 6x squared minus 8x plus 24. Right? Same questions. Find the list of possible rational zeros. Factor f of x completely. Right, and 3, find the multiplicities and their find the x-intercepts. And their multiplicities. So why this exercise is different from the previous one? That's because this is of degree 4, right? The polynomial f of x is of degree 4. So when you divide and when you when you compute when you divide and compute your quotient, so your quotient is gonna be of degree 3, not degree 2, right? So the quotient is gonna be degree 3, and then you have to factor the quotient, which is of degree 3, right? So I'm gonna give you guys let's say 5-10 minutes to think about this exercise, all right? So as I said, this is really important remark. This is different from the previous exercise because the quotient in this case is going to be quotient is going to be of degree 3, not so the quotient is of degree 3. Yes, Kwame, 2 is going to be a solution. Yes, absolutely, yes. Correct, very good.
Sir, we are beginning from x to the power 3, right?
Yes.
So would it be a 0 or to be a 1? Because we can't leave the 0, we can't leave the x to the power 3 as 0, or we can.
I don't really understand your question. So this is in the question number 2, when you factor f of x completely.
Yes.
All right. So you said so 2 is the solution, right?
Yes.
So you divided f of x by x minus 2.
Yes.
And
usually we begin from the next number.
Oh,
Yeah.
yeah, because now the quotient is a degree 3, right? And
Yes.
so it's not possible to use the quadratic formula, right?
Yeah.
And you can think of partial factoring, but actually the partial factoring won't work. So yes, you have to use again this possible rational zeros. Yes,
Oh,
absolutely.
okay. Okay. Okay.
Yeah. So in the homework, guys, I mean, problems 5 and 6, right? Both of them, the function f is of degree 3, right? So they are just similar to the exercise, to the previous exercise we had, right? So this exercise, again, it's kind of different from the problems in the homework because your function f here is of degree 4, right? Well, then, so then I don't know. So then I no. So I think it's not correct because I mean, how did you get the 2x cubed? Should be 1x cubed. I don't see why it's 2x cubed. Should be 1x cubed. All right. So anyway, guys, because we don't have much time, like we have like 8 minutes, and that's barely enough to probably do the just 1 or 2 questions here. So number 1, the list. So that's the factors, factors of 24 over factors of 1. So you factors of 24. So we have 1 divided by 1, it's 1. 24 divisible by 2, divisible by 3. 3 times 8 is 24. 24 is divisible by 4. 4 times 6 is 24. Not by 5, but it's divisible by 6. Divisible by 8. 8 times 3 is 24. Divisible by 12. 12 times 2 is 24. And finally by itself, 24. Right? So this is the list of possible rational zeros, right? Now, you want to factor f of x completely, right? So first, we said you have to check these numbers in the list, see if we get the solution, right? So if you check, let's say, first number is 1. So if you check, let's say f of 1, positive 1, that'd be 1 minus 6 minus 8 plus 24, which is obviously not 0. So 1 is not a solution. If you check negative 1, so it's positive 1, again minus 6 plus 8 plus 24, which is obviously not 0, right? So neither positive 1 or negative 1 are solutions. Now let's try positive 2. So if you try positive 2, then let's see. So 2 to the power 4, that's 16, minus 6 times 4, minus 24, minus 8 times 2, that's 16, so minus 16 plus 24. So 16 minus 24, 16 minus 16 cancel out, minus 24 plus 24 cancel out, so that's 0. Right? So 2 is the solution, right? So we're going to divide now. So now step 2. So we have to divide. This is step number 2. We divide divide f of x by our solution, right? So my x minus 2. So your c is positive 2, right? So so then, oops. So then, so here's my positive 2. Now, what about f of x? So f of x is, so x fourth, x cubed, x squared, x, and then constant. So x fourth, we have 1 x fourth. How many x cubed? There's no x cubed, so it's 0. X squared, it's minus 6x squared. X, we have minus 8x, and the constant is 24, right? So bring down 1 here. 2 times 1 times 2 is 2. This is plus. So 0 plus 2 is 2. 2 times 2 is 4. Negative 6 plus 4 is negative 2. 2 times negative 2, it's negative 8. Negative 8 plus negative, sorry, it's negative 4. Negative 8 plus negative 4, it's negative 12. Negative 12 times 2, it's negative 24. And 24 plus negative 24 is 0. So as expected, we get 0. All right, that's our remainder. And then the quotient, this is supposed to be 1 degree less, so it's x cubed, x squared, this is x, and this is constant. So I guess you, Kwame, in your answer, you got, so you forgot 1, right? It's 1x cubed plus 2. So the quotient, so here the quotient would be 1x cubed plus 2x squared minus 2x minus 12, right? Now, in the next step, guys, step 3, we have to factor this quotient, right? So let me, before the step 3, so your f of x, so what we are saying is our f of x is equal to the divisor. I divide by x minus 2 times the quotient times the x cubed plus 2x squared minus 2x minus 12. So now I have to factor this x cubed, etc., right? Factor this. Right? So that will be the next step. I have to factor this x cubed. So step 3. So we have to factor x cubed plus 2x squared minus 2x minus 12, right? Now the thing is, this is not a quadratic function, right? This is, here the power is 3, right? So it's not a quadratic function, so I cannot easily use the quadratic formula, right? So how do you factor this x cubed plus 2x squared, etc.? Well, you can try partial factoring, of course. You can try to factor or partial factoring. Try factoring or partial. So we can try to factor this, but the thing is, there's no common factor, right? X is not the common factor. So we have to try partial factoring. Factoring. But even if you try partial factoring here, you see there's this x. You can, for example, factor out x squared, but then you have x squared times x plus 2. And here you can factor out minus 2. So that will be minus 2, for example, x plus 6. But this is not x. This is not the common factor, right? So partial factoring here doesn't really work, right? So then what we can do is you can try again our possible rational zeros. So then, so it doesn't work, and it doesn't work, it doesn't work. Okay, so then we can try the numbers in the list of possible rational zeros. Possible rational zeros, right? I mean, so what I'm saying is that, you know, we have this x cubed plus 2x squared, right, minus 2x minus 12. So then the list of possible solutions here, this is negative 12, right? So that would be negative plus or minus 1, again, plus or minus 2, factors of 12, right? Factors of 12, 3, 4, 6, and then of course plus or minus 12. So you can try to see if these numbers are solutions of this, right? And then you can divide by x minus the solution you get. So for example, if you try 1, if you try 1, then 1 is not the solution. If you try 2, so for example, if you try 1, then you're gonna have 1 cubed plus 2 minus 12, that's not 0. You can try negative 1. You can try positive 2, right? So for example, you try positive 2, then you're gonna have 2 cubed, that's 8, plus another 8, minus 4, minus 12. So you get 0, right? If you try positive 2, if you plug 2 here, right, you get 0. So then that means that actually 2 is a solution of this quotient. So what we can do is we can divide. So 2 is a solution. So then you can divide our quotient. Yes, Samir, absolutely. So we can divide the quotient by x minus 2, right? Because I tried 2, and actually 2 turns out to be a solution again, right? So then divide the quotient by x minus 2, and then so once you divide the quotient by x minus 2, so then you have to repeat the same process, right? Then you have to factor the new quotient, right? Etc. etc. Sorry guys, I went over time, so I guess I'm gonna stop here. But all I'm saying here, divide the quotient by x minus 2, and then repeat the same process, repeat the same steps, repeat the same steps with the new quotient, same steps with the new quotient, right? Anyway, I'm gonna stop here, guys, and I will start, I guess, next time on Wednesday. I will see you on Wednesday, and I'm gonna start a new section, section 2.6. So please don't forget your homework. It's due this Wednesday, and I will see you on Wednesday. Thank you, everyone. Thank you so much.
Hi, Professor.
Bye. See you next time. Take care.
Hello.
Yes.
Yeah, it's Mamadou Diallo. I came late. I was not here for the attendance.
Oh, okay. I got you. Thank you.
Okay, fine. Thank you so much.
Thank you. Is there
Professor?
a question? Yes.